Welcome to RPS Group of Schools online classes. This is session 4 for the chapter Light. In today's session, we will study about lenses and image formation by different types of lenses. A lens is a piece of transparent medium that is bound by two surfaces, at least one of which is curved. A lens is generally made up of glass or plastic. Based on their structure, lenses may be convex or concave. Convex lens. A lens which has a bulge at the center and is narrow towards the edges is called a convex lens. Based on the structure of the two surfaces, convex lenses may be of the following types. Biconvex lens that has two outward curved surfaces. Plano-convex lens that has one plane and one outward curved surface. Concavo-convex lens that has one concave, that is inward curved surface, and one convex, that is outward curved surface. Convex lens converges rays of light at a point, and so it is also called converging lens. Concave lens. A lens which is thin at the center and thick towards the edges is called a concave lens. Based on the structure of the two surfaces, concave lenses are of following types. Biconcave lens with two inward curved surfaces. Plano-concave lens with one plane and one inward curved surface, and convexo-concave lens with one outer curved and one inward curved surface. Concave lens spreads the ray of light falling on it and is called diverging lens. Let us study some important terms related to lenses. Optical center. The central point of a lens is called its optical center. It is denoted with the letter capital O. A ray of light passing through optical center of a lens remains undeviated. Center of curvature. The center of the sphere of which lens is a part is called center of curvature. It is denoted with the letter capital C. Since a lens is made up of two curved surfaces, each lens has two center of curvatures. Principal axis. The imaginary line that passes through the center of curvatures of a lens is called principal axis. Radius of curvature. The distance between the optical center and center of curvature is called radius of curvature. Principal focus or focal point. The point at which light rays parallel to the principal axis converge in case of convex lens or appear to be coming from in case of concave lens is called focal point or principal focus. Focal point is represented by the letter capital F. A lens has two focal points marked as F1 and F2. Focal length. The distance between optical center and principal focus is called focal length of a lens. Any point which is at a distance twice the focal length, is marked as 2f. Let us discuss the image formation by convex lens. The nature of the image formed by a convex lens depends upon the position of the object. For most of the positions of the object, the image formed in case of a convex lens is real and inverted. When the object is close to the convex lens, an erect, virtual and enlarged image is formed in the lens. As the object moves away from the lens, an inverted, real and enlarged image is formed on the screen. If the object moves further away, an inverted, real and diminished image is formed on the screen. Let us study each case in detail. When the object is present at infinite distance. When the object is at an infinite distance from the convex lens, the image formed is inverted, real and diminished, that is smaller than the object. Object beyond 2f. When the object is beyond 2f, the image formed is inverted, real and smaller than the object. Object at 2f. When the object is placed at 2f, that is at a distance twice the focal length, the image formed is inverted, real and of the same size as the object. Object between focal point and 2f, that is a point at a distance of twice the focal length. When the object is between f and 2f, the image formed is inverted, real and larger than the object. Object at focal point. When the object is placed at focal point, a real, inverted and highly magnified image is formed at an infinite distance. Object between focal point and optical center of the lens. When the object is placed between focal point and optical center, the image formed is erect, virtual and larger than the object. Let us discuss image formation by concave lens. The image formed by concave lens for any position of the object will have the following features. The image will be virtual and erect. Size of the image will be smaller than that of the object. The image will be formed inside the lens because reflected light rays appear to come out from a point inside the lens but do not intersect in reality. That was all for today's session. Thank you.